Hello, morning, everyone. So today I have an interesting topic in chemistry. So we're doing chemistry 1-1 today. Okay, chemistry 111. Okay, just waiting for people to join so that we start the session. At least two or three people watching. We start the session. I've seen people that they've started following. So redox reaction, okay? Redox reaction. So redox reaction. So what is redox reaction? So redox reaction actually is the one that has both reduction and oxidation taking place simultaneously. It's the one that has both reduction. We may be writing. You need to have a pen paper or a book. You should be writing the points that you are seeing are very important to you. Okay. So redox reaction is the one that has both reduction and oxidation taking place simultaneously. Okay. Taking place simultaneously. Okay, so that is a redox reaction. So we will split redox reaction into reduction and oxidation reactions. Okay, so you need to know these terminologies. They are the most used in when you are given a question to answer on this redox reaction. So what is so the terminologies that you look at this time around is this one. Let me just highlight them underline them in the same definition. We'll look at oxidation and also look at reduction. What do these actually mean? Oxidation and reduction. Okay. Excuse. So oxidation. So oxidation. So actually this one, I will give you two important definitions that you need to know about oxidation. There are two which are important and two which are not important. Okay. There are two that are important that you're going to be using in the equations. And there are other two, they are not important. So the important ones, oxidation, number one, is the loss of electrons. Oxidation is the loss of electrons. So important ones, important definitions of oxidation. Alright. So the first one is oxidation is the loss of electrons. Is the loss of electrons. Okay, so this is important. It's the loss of electron. Another important definition is the increase in oxidation number. Okay, is the increase in oxidation number. The increase in oxidation number. Okay, so this is important. So other ones which is not important, you will hear the defining by the gain of oxygen. It also the definition of oxidation. It's the gain of oxygen, also the loss of hydrogen, but it's not important. So you just take these ones, the first two I've given you. Okay, so let's look at reduction. So reduction, the two important definitions that you need to know. There are two important definitions that you need to know. Important ones about reductions. Number one is that reduction is the gain of electrons. It's just the opposite of oxidation. Oxidation, I said, is the loss of electrons. You're losing electrons. For reduction, you are gaining electrons. Okay, so it's the gain of electrons. So this one is the gain of electrons. You're gaining electrons. So another important definition is that reduction is a decrease in oxidation number, just like the opposite of oxidation. So this one is the decrease in oxidation number. Okay, so the decrease in oxidation number. Other definitions of reduction. Is that one is the loss of oxygen. Two is the gain of hydrogen. So this is not important. Well, there is a mnemonic that I'm going to give you that for you to be remembering what oxidation and what reduction is. So this is the mnemonic. Or you can say mnemonic here. So okay, so this is the memo head for you to be remembering what reduction and what oxidation is. So what O means is, O means oxidation involves loss. So meaning oxidation is the loss of electrons. So oxidation involves loss, then reduction involves gain. So reduction is the gain of electrons. So this one is oxidation involves loss. Okay, oxidation involves loss. Oxidation involves loss. Then this one, you see, reduction involves gain. Reduction involves gain. Okay, so we need to be remembering this mnemonic. Oil leak. Oil leak. Okay, oil leak. Oil leak. What other terminologies that you need to be familiar with? What if they say oxidized, reduced, these terms? So when they say okay, so when they say oxidized, what do they mean when they say terminologies? We see one terminologies. So what do they mean when they say oxidized? Oxidized. Let's say sodium is an oxidizing agent. Whatever is oxidized, shan is reduced. You get? So oxidized, they mean there is a loss of electrons. There is loss of electrons. Then two, the oxidation number increases. The oxidation number increases. The oxidation number increases. What else? So when the oxidation number is increased, that means that that thing you're dealing with is a reducing agent. Reducing agent. Okay. What if they say reduced? Something is reduced, meaning you have gained electrons. So it means there is electron gain. So gains electrons. What else? Oxidation, just the opposite. Oxidation number decreases. Oxidation number decreases. Then what will be the agent? The agent will call it an oxidizing agent. Okay. I'm sure people are fighting the network issue. Okay, we proceed. You go through the recorded video if you failed to access the live broadcast. So let's have an example and try to display what the terminologies that I've taught you. Okay, so example. Let's have two sodium, which is in solid state, plus chloride in gas, giving us two sodium chloride. Okay, so this one, the first thing that I need to about the oxidation number, I'll explain. Let's say this one has an oxidation number of 0. So this one has an oxidation number of 0 because it's in natural state. So element in natural state have the oxidation number of 0. Okay. Element in their natural state have the oxidation number of 0. So even this one, see, 0. Okay. But this is an ion, sodium chloride. If you split it, it's an ion. So this one has a oxidation number of 1, positive 1 for the sodium. Let's say this one will give us 1. Don't worry, I'll show you how to calculate the oxidation number. So for this one, it's negative 1. Okay. So meaning from here, we're seeing what you have in. From here, we're going to say sodium is oxidized. Sodium is oxidized and chlorine is reduced. Let me explain. Sodium. Why? Because initially the sodium was having the oxidation number of 0. Okay, that's why we are saying it's oxidized. What are the terminologies under oxidized atom? Did I say there will be loss of electrons? Okay, there will be loss of electrons. When there is a positive, means it's the loss of electrons. Then the oxidation number increases. So the oxidation number here is 0. So here we're having positive 1. You have see? So the oxidation number has increased. So what will be the agent? What agent are we going to call it? It's a reducing agent. What agent are we going to call it as a reducing agent? Okay. So from here we're going to say chloride. Chloride will be called the oxidizing agent. Or oxidizing agent meaning it's an electron acceptor. So chloride will be called oxidizing agent. Oxidizing agent. When it's an oxidizing agent, that means it's an electron acceptor. Electron acceptor. Okay. Then sodium will be called reducing agent. Okay, reducing agent, because there is loss of electrons, the oxidation number increases. Okay, so this will be electron donors, the one giving electrons. It's the one giving out electrons. So this is an electron donor. Okay. Now let me show how to calculate the oxidation numbers. How to calculate the oxidation number. Okay. How to calculate the oxidation number. How to calculate the oxidation number. How to calculate the oxidation number. So let me give you the points that you need to consider as you be calculating the oxidation numbers. Okay. So number one, first thing that you need to know when you're calculating the oxidation number. So the element in their natural state have an oxidation number of 0. Element in their natural state have an oxidation number of 0. So let me give you the example. E.g., let's say we have chloride. Right. So this chloride in gaseous state is in natural form. So this has oxidation number of 0. Sodium in a solid 0. Iodine. Okay. Then bromine. So in their natural state, you have an oxidation number of 0. 2. The oxidation number of ion is equal to its charge. Okay. The oxidation number of an ion is equal to its charge. Okay. So the oxidation number of an ion I'm sure you know when I say ion, okay. So let's have an example of oxygen, having -2 like this. So this is an ion, So I'm saying the oxidation number of that an ion will be equivalent to the charge that it is carrying. So this has a charge of -2. So meaning it has the oxidation number of 2. -2. There's a negative, sorry. So -2. So let's say if you're having nitrogen N2, so meaning this one has the oxidation number of -2. Chloride has the oxidation number of like this. As long as it's an ion, the oxidation number will be equivalent to its charge. Okay, copper, you have copper, +1, ion 2, copper 2, copper 2 have like this. Okay, an ion. Okay, so so what about the common? So we need to know about the common oxidation numbers also. So common oxidation numbers that you need to know. Common oxidation numbers. So let's say you have sodium. Sodium has the oxidation number of 1, positive 1. As long as, okay, let me say when it's in group 1, right? Sodium in group 1 have the oxidation number of 1, potassium like that. Okay, these are common oxidation numbers. Sodium positive 1, you can have potassium is also positive 1, oxygen negative 2. These are common oxidation numbers. Hydrogen positive 1, and this is negative 1. Okay. So another point that you need to know about the oxidation number is the sum of the oxidation number of all the species in the compound equals to the overall charge. Which charge I'm saying is the overall charge. Okay, the sum of the oxidation number. Let me write. The sum of the oxidation number of all the species, the sum of the oxidation number of all the species in a compound equals the overall charge. Equals the overall charge. Okay, let's have magnesium tetraoxide like this, Mn or then 4 minus. So this charge here is the one I'm saying it's the overall charge. So when there's just a negative, meaning it's a 1, it's a negative 1. So let's find the oxidation number of manganese. So this one. Okay. So this, we're going to select this be xi. We're going to have xi. So x plus how many atoms of oxygen? We have 4. We're going to say 4 times what is the common oxidation number of oxygen? The common oxidation number of oxygen that I said you need to know is negative 2. Then it's supposed to be equal to the overall charge is negative 1. Okay. Then you find the value of x. X, this will be minus 8. Should be equal to negative 1. So x should be negative 1 plus 8. So the value of x will be positive 7. Okay, so meaning this one has the oxidation number of positive 7. That's how you find the oxidation number. Okay, let me give the question now. We try the question on oxidation number. Then we move on to balancing acidity and basic need. Find the oxidation. Find the oxidation number of the following. Find the oxidation number of the following. Okay, 1. Let's have this one. Okay, then 2. Okay, 2. So we calculate the oxidation number for this one first, then we also calculate for this one. Okay, so let's find the oxidation number for this one. So let this be xi. Okay, so x plus, then how many atoms of oxygen? 3 times negative 2. Then this should be equal to the overall charge, negative 1. Then the value of x will be minus 6, being equal to negative 1. X will be negative 1 plus 6. The value of x will be 5, positive 5. Okay, so meaning this one having the charge of oxidation number, which is 5, then this one up to this one, so I'm moving from this to this. So this one has the charge, so the oxidation number of an ion is equal to its charge. Okay, so for this one, the oxidation number will be equal to +3. So you can see you're moving. So this one, initially you had 5, then you had 3 as the product. So the oxidation number is reduced from 5 to 3. Therefore, that is reduction. So you're going to conclude to say, therefore, the oxidation number has been reduced from 5 to 3. Therefore, that is reduction. I think this is simple and straightforward. Another one, the last one on oxidation numbers. You can have this any 2 or 4 to N2 or okay. So let's calculate for this one. So if you're having a subscript there, make sure the subscript become the coefficient. So you want to find the oxidation number for this one, nitrogen. You're going to say it will be 2xi plus, then having 4 oxygen, 4 times -2 should be equal to, what is the overall charge? So there's no charge on top, so the overall charge is 0. So we're going to say 2x minus 8 should be equal to 0. So 2x should be equal to 8. Then the value of x will be +4. What about this one? We also need to calculate. We have 2, the subscript to 2. We're going to say 2x plus 1 times -2 should be 0. Then 2x should be equal to 2. Then the value of x will be 2. Will be 1. Sorry. So x will be +1. So initially you had 4 as the oxidation number, then you are ending up with 1. So meaning that is the reduction also. The oxidation number, because has been reduced from 4 to 1. Okay. Let me give another one that you need to try on your own time if you are following. So you need to try this. Try this. 2. This. Okay. So let's now see how we can be coming up with the half reaction, oxidation half reaction, reduction half reaction. So let's say you've been given we're looking at half reactions now. Oxidation half reaction and reduction half reaction. So let's have this equation. That's 5 carbon monoxide being equal to 5 plus this. Okay, so the first thing that you need to do, you need to find the oxidation number of each of the elements. Okay, so let's find the oxidation number for this one, and we see what we are ending up with. We also for this one, and we see what we are ending up with. Then you isolate the oxidation half reaction and the reduction half reaction. From there, when you know, that's when you can now start balancing the acidic media and the basic media thing. So let's calculate for this one. Let's have I'm sure you know if you have been following. So this will have a subscript of 2, so 2 will be the coefficient, 2x, then plus 5 times negative 2. The overall charge is 0. Okay, 2x minus 10 should be 0, so 2x is 10 and the value of x is 5. Okay, yeah, so for this one we have 5 there. So for this one, ignore the balanced coefficient for this one. Don't take the balanced coefficient already. So just take unless it was the subscript. Okay, so for this one I'm just going to say x plus then 1 times negative 2. What is the overall charge? 0. So x minus 2 equal to 0. So the value of x is 2. So 2 is the oxidation number of carbon monoxide. Also go for this one. Here we have x then plus 2 times negative 2 equal to overall charge 0. So meaning the value of x, meaning for this carbon dioxide the oxidation number is 4. Okay, so now for this one, how did this one? This one is in its natural state. If you follow to the first pointer that I gave you initially, I said the element in their natural state have the oxidation number of 0. So for this one, it's in its natural state, meaning the value of x is 0. So because it's in its natural state, that's why you are giving it a 0. Okay, so now let's isolate or split which one is the oxidation half reaction and which one is the reduction half reaction. Okay, for this one, let's see the oxidation number of iodine. So here we have 5. Then we are ending up with a 0. So we have 5, then you are ending up with the 0, meaning it's a reduction. The oxidation number is reached from 5 to 0. So meaning having a reduction half reaction. So reduction half reaction. So the reduction half reaction will be this one. Okay, to this. So this is our reduction half reaction. Because the oxidation number has reduced from 5 to 0, that is reduction, hence carbon. So meaning, what are we going to say? From here, which one is the reducing agent? So meaning carbon monoxide. Alright. So meaning carbon monoxide is our reducing agent. Meaning carbon monoxide is our reducing agent. Okay. Then let's have the oxidation half reaction. So if we split we know the reduction half reaction, meaning automatically we're going to know the oxidation half reaction. So let's have our oxidation half reaction. Okay, so meaning our oxidation half reaction is 5 carbon monoxide being equal to this, okay, carbon dioxide. So oxidation number has been increased from 2 to 4. So we had 2 here, 2, then we are ending up with 4. So meaning the oxidation number has increased. So this is oxidation half reaction. So our oxidizing agent is iodine. This is our oxidizing agent. Okay, so I think you know now how to split the reaction, the half reaction. Okay. Now we can now move to balancing redox reaction. I give you the steps. There are two methods you can balance redox reactions. Okay, but I'll give you the simple one. We move now to balancing redox reaction. Okay. Number one, we have the oxidation number of balancing. Two, we have the half reaction method, like the one I showed you. For the half reaction is the one actually which is simpler. For the other one, it's short, but people get confused. So I will show you for the one with the half reaction, but you need to know the steps. So I'll give you the steps, or let's say the pointers that you need to know for balancing redox reactions. Okay. So balancing redox reaction in acidic media. So steps for balancing redox reaction in acidic media. Okay. So the first step, we need to divide the reaction into half reactions and assign the oxidation number. Divide the reaction into half reactions and assign the oxidation number. Okay. Divide reaction into half reaction, which you know now, and assign the oxidation numbers Okay. 2, balance atoms other than hydrogen and oxygen. You need to balance the atoms other than hydrogen and oxygen. Balance atoms other than hydrogen and oxygen. Okay. Step 3, what you need to know, you need to balance oxygen by adding H2O water on the side deficient with oxygen. Balance oxygen by adding H2O on the side deficient, on the side you are lacking oxygen. Okay, so balance oxygen by adding H2O on the side deficient with the oxygen. Okay. Number 4 pointer that you need to know, you need to balance hydrogen by adding hydrogen ion on the side deficient with hydrogen. Okay, you need to balance hydrogen by adding hydrogen ion on the side deficient with hydrogen. Okay. Another thing that you need to know, Step 5. From there, I need to balance now the net charge. Balance the net charge. Balance the net charge. Okay, balance the net charge. Another thing, you need to balance the electron gain. Should be equal to electron loss and the two half reactions. Okay, balance electron gain. Balance electron gain being equal to electron loss and the two half reaction and the two half reactions. Then from there, when you do that, you need to cancel anything that is common on both sides of the equation. You need to cancel anything that is common on both sides of the equation. Okay, I think this is the last one. You need to cancel anything that is common on both sides of the equation. So we're having how many steps? 7, eh? So 1, 2, 3, 4, 5, 6, 7. Okay. So this is very important. These are the steps that you need to know. Okay, so I'll begin with the example on balancing in acidic media.